question at hand involves installing metal-clad cable to a metal box within a stud space used for air handling, considering both the International Residential Code (IRC) and the National Electrical Code (NEC). The 2003 IRC version lacks specific regulations about device or box installations within cold air returns. However, the 2006 IRC, Section E3804.7 prohibits running non-metallic covered wire through stud and joist spaces that serve as air ducts. Because of this, using metal-clad cable connected to a metal box in a 2/6 stud space used for air handling seems to meet the IRC requirements. The National Electrical Code, or NEC, however, typically governs electrical installations. NEC Section 300.22b has clear restrictions banning the installation of devices and equipment inside cold air returns. So, placing a metal box in a cold air return probably does not comply with the NEC even if the IRC appears to allow it. To clarify this, it is best to speak with the local building inspector. They determine if installing a metal box in the air return is permissible in the specific location. If not approved, the metal box needs to be placed somewhere else. Section 300.22 of the NEC addresses wiring in ducts used for dust, loose stock, or vapor removal and for environmental air. Part of the section covers ducts specifically for dust, loose stock, or vapor removal systems. These are not environmental air systems. Part B focuses on ducts or plenums used for environmental air. This includes spaces above suspended ceilings or other structural components used for air handling. Key aspects of Section 300.22 are that wiring methods must be metal raceway, metal-clad cable, or Type MC cable without an overall non-metallic jacket. Electrical equipment must be completely enclosed in any opening seal to prevent sparks or flames from escaping. Temperature limitations are also important. Equipment must operate at a temperature not exceeding 140 degrees Fahrenheit unless specifically identified and listed for higher temperatures. Part B of 300.22, covering environmental air, has additional requirements. Firstly, it specifies the wiring methods permitted in ducts and plenums. These include metal raceway systems, metal-clad cable, and Type MC cable, similar to Part A. However, Part B emphasizes that these wiring methods must be suitable for the conditions, including temperature and humidity. Secondly, it restricts the types of equipment allowed in these spaces. Only equipment that is directly associated with the air distribution system is permitted. This means that general-purpose electrical equipment, such as receptacles, lighting fixtures, and junction boxes, is typically prohibited unless it is essential for the air handling system's operation or maintenance. Thirdly, it mandates that any equipment installed in these spaces must be designed and installed to minimize the accumulation of dust and debris. This helps to maintain the air quality and prevent fire hazards. Furthermore, all equipment must be accessible for inspection and maintenance. Fourthly, it requires that wiring and equipment must be supported independently from the suspended ceiling or other structural components. This prevents the weight of the electrical system from placing undue stress on the air distribution system. The section also addresses specific types of wiring and equipment. For example, it allows for the installation of listed plenum cable and plenum raceway in plenums used for environmental air, provided that they meet specific fire resistance and smoke emission requirements. These cables and raceways are designed to minimize the spread of fire and smoke in the event of a fire. In addition, Section 300.22c covers other spaces used for environmental air. This section allows for the installation of electrical equipment and wiring in spaces such as raised floors used for data processing equipment, provided that certain conditions are met. These conditions include the use of metal raceway systems, metal-clad cable, or Type MC cable, as well as the installation of smoke detectors and fire suppression systems. To summarize, NEC Section 300.22 provides detailed requirements for wiring and equipment in ducts used for dust, loose stock, or vapor removal and for environmental air. These requirements are designed to minimize the risk of fire and electrical shock, as well as to maintain air quality. When installing electrical systems in these spaces, it is essential to carefully review and comply with all applicable requirements of Section 300.22, along with any other applicable codes and standards. Additional key points from the NEC include that wiring methods must comply with Chapter 3 of the NEC, which covers wiring methods and materials. Equipment must be suitable for the environment, including temperature, humidity, and corrosive conditions. All installations must be performed by qualified personnel in accordance with the NEC and any local codes. Consideration of the specific application is crucial. For example, in a data center, raised floors used for environmental air often require special attention to grounding and bonding to minimize the risk of electrical noise and interference. Similarly, in healthcare facilities, electrical systems in air handling spaces must meet additional requirements to ensure patient safety. The interaction between the NEC and other codes and standards also needs to be understood. For example, the International Building Code (IRC) also includes requirements for air handling systems, including fire resistance ratings and ventilation requirements. These requirements must be coordinated with the NEC to ensure a safe and compliant installation. Always refer to the latest edition of the NEC and any applicable local codes. Codes and standards are subject to change, so it is essential to stay up to date on the latest requirements. Consult with qualified electrical engineers and contractors who have experience with these types of installations. They can provide valuable guidance and ensure that the installation meets all applicable requirements. The NEC is a comprehensive code that addresses a wide range of electrical safety issues. Section 300.22 is just one small part of this code, but it is an important part for ensuring the safety of buildings and their occupants. The NEC provides tables for ampacity, which is the current carrying capacity of conductors. These tables are essential for determining the appropriate size of conductors for different applications. For example, Table 310.15. B16 provides the allowable ampacities of insulated conductors rated up to 2000 volts based on the conductor's insulation type, size, and ambient temperature. The NEC also provides requirements for overcurrent protection, which is designed to protect conductors and equipment from overloads and short circuits. Overcurrent protection devices, such as fuses and circuit breakers, must be sized appropriately to protect the circuit. The NEC also includes requirements for grounding and bonding, which are essential for preventing electrical shock hazards. Grounding provides a path for fault current to flow back to the source, while bonding ensures that all metal parts of the electrical system are at the same potential. The NEC also addresses the installation of electrical equipment in hazardous locations, such as areas where flammable gases or vapors are present. These locations require special equipment and wiring methods to minimize the risk of explosion. The NEC is a living document that is constantly being updated to reflect new technologies and safety concerns. It is essential to stay up to date on the latest edition of the NEC to ensure that electrical installations are safe and compliant. Furthermore, the NEC requires that all electrical work be performed by qualified personnel. This helps to ensure that the work is done safely and in accordance with the code. In addition to the NEC, there are other codes and standards that may apply to electrical installations. These include the International Building Code, the International Fire Code, and various product safety standards. It is important to be familiar with all of the applicable codes and standards to ensure a safe and compliant installation. The NEC also provides guidance on energy efficiency. For example, it includes requirements for lighting controls and energy-efficient motors. These requirements can help to reduce energy consumption and save money on utility bills. The NEC also addresses the issue of electromagnetic compatibility, or EMC. EMC refers to the ability of electrical equipment to function properly in the presence of electromagnetic interference. The NEC includes requirements for minimizing electromagnetic interference and ensuring that equipment is compatible with its environment. Furthermore, the NEC provides requirements for surge protection. Surge protection devices can help to protect electrical equipment from damage caused by voltage surges, such as those caused by lightning strikes. The NEC also addresses the issue of power quality. Power quality refers to the stability and reliability of the electrical power supply. The NEC includes requirements for minimizing voltage sags, swells, and other power quality disturbances. Moreover, the NEC provides guidance on the selection and installation of electrical equipment. This guidance can help to ensure that equipment is properly sized and installed for its intended application. The NEC also includes requirements for labeling and marking of electrical equipment. This labeling helps to identify the equipment and provides important information about its ratings and characteristics. In addition, the NEC provides requirements for the inspection and testing of electrical installations. These inspections and tests help to ensure that the installation is safe and compliant with the code. The NEC also addresses the issue of arc flash hazards. Arc flash is a dangerous electrical phenomenon that can occur when there is a short circuit in electrical equipment. The NEC includes requirements for arc flash hazard analysis and for the use of personal protective equipment to protect workers from arc flash hazards. Furthermore, the NEC provides guidance on the design and installation of renewable energy systems such as solar photovoltaic systems and wind power systems. These systems require special considerations to ensure that they are safe and reliable. The NEC also addresses the issue of energy storage systems such as batteries and other energy storage devices. These systems are becoming increasingly common as a way to improve the reliability and efficiency of electrical power systems. In addition, the NEC provides requirements for the installation of electric vehicle charging equipment. This equipment is becoming increasingly common as electric vehicles become more popular. The NEC also addresses the issue of smart grid technologies. Smart grid technologies are designed to improve the efficiency and reliability of the electrical power grid. These technologies require special considerations to ensure that they are safe and secure. Furthermore, the NEC provides guidance on the design and installation of high-voltage electrical systems. High-voltage systems require special precautions to ensure that they are safe and reliable. The NEC also addresses the issue of electrical safety in healthcare facilities. Healthcare facilities require special electrical systems to ensure the safety of patients and staff. In addition, the NEC provides requirements for the installation of electrical equipment in industrial facilities. Industrial facilities often have unique electrical needs and require special considerations to ensure that their electrical systems are safe and reliable. The NEC also addresses the issue of electrical safety in agricultural facilities. Agricultural facilities often have unique electrical hazards and require special precautions to ensure that their electrical systems are safe. Furthermore, the NEC provides guidance on the design and installation of temporary electrical systems. Temporary electrical systems are often used for construction sites, fairs, and other temporary events. The NEC also addresses the issue of electrical safety during emergencies. Emergency electrical systems are designed to provide power during power outages and other emergencies. In addition, the NEC provides requirements for the decommissioning of electrical systems. Decommissioning electrical systems requires special precautions to ensure that they are safely removed and disposed of. The NEC is a comprehensive and complex code that addresses a wide range of electrical safety issues. It is essential to be familiar with the NEC and to follow its requirements to ensure that electrical installations are safe and compliant. To recap the specific scenario, one needs to consider the local interpretation and amendments to both the IRC and NEC. Local jurisdictions often adopt and modify these codes to suit their specific needs and conditions. These local amendments can significantly impact the permissibility of certain electrical installations. Therefore, it is always crucial to consult with the local building inspector or authority having jurisdiction to determine the specific requirements that apply in a given area. Secondly, the type of air return system is important. The NEC distinguishes between different types of air handling spaces, such as ducts and plenums. A plenum is a space used for the conveyance of environmental air, while a duct is a more defined channel. The requirements for wiring and equipment in these different types of spaces can vary. Therefore, it is necessary to determine the specific type of air handling space in question in order to apply the correct NEC requirements. Thirdly, the intended use of the metal box needs to be considered. If the metal box is intended to house equipment that is essential for the operation of the air distribution system, such as a motor starter for a fan, it may be permissible to install it in the air return, provided that all other applicable requirements are met. However, if the metal box is intended to house general-purpose electrical equipment, such as a receptacle or a lighting fixture, it is likely to be prohibited. Fourthly, the construction of the metal box is a factor. The NEC requires that all electrical equipment installed in air handling spaces be designed and installed to minimize the accumulation of dust and debris. This means that the metal box should be tightly sealed and should not have any openings that could allow dust or debris to enter. Additionally, the materials used in the construction of the metal box should be non-combustible and should not produce any harmful emissions when exposed to heat. Fifthly, the method of supporting the metal box must be evaluated. The NEC requires that wiring and equipment in air handling spaces be supported independently from the suspended ceiling or other structural components. This means that the metal box should be securely fastened to the building structure using appropriate hardware. The support system should be designed to withstand the weight of the metal box and any equipment that it contains. Sixthly, the wiring method used to connect to the metal box must comply with the NEC. The NEC allows the use of metal raceway systems, metal clad cable, and Type NC cable in air handling spaces, provided that they are suitable for the conditions. The wiring method should be properly supported and secured, and all connections should be made in accordance with the NEC requirements. Seventhly, the overcurrent protection for the circuit supplying the metal box must be considered. The NEC requires that all electrical circuits be protected by overcurrent protection devices, such as fuses or circuit breakers. The overcurrent protection device should be sized appropriately to protect the circuit from overloads and short circuits. Eighthly, the grounding and bonding of the metal box must meet the NEC requirements. Grounding and bonding are essential for preventing electrical shock hazards. The metal box should be properly grounded and bonded to the building grounding system in accordance with the NEC requirements. Ninthly, the labeling and marking of the metal box must comply with the NEC. The NEC requires that all electrical equipment be properly labeled and marked to identify its ratings and characteristics. The metal box should be labeled with its voltage, amperage, and other relevant information. Tenthly, the inspection and testing of the electrical installation are essential. After the metal box has been installed, it should be inspected and tested to ensure that it is safe and compliant with the NEC requirements. The inspection and testing should be performed by a qualified electrical inspector.